So we are now going to actually apply what we've just talked about to some equations. I've titled this solving trig equation with ranges bigger than 0 to 360. Technically, we might actually have to consider those ranges smaller than that, but at the moment, focus on bigger than. So for our first question here, standard question from last week, sine of x equals minus 0.26. But today we're working with a range which is between 0 and 720. So our starting maneuver with this is going to be very similar to what we've done before. So we're going to do x equals sine to the minus 1 of minus 0.26. Put that in our calculator. It will turn out minus 15.07 degrees. If you're going to use cast, you'll do sine to the minus 1 of 0.26 here and get 15.07. Because we're working with sine, these look very similar, the minus sign being the difference. Obviously, I'm going to work through I'm going to work through the graph method first. Graph looks like that. Here's 360, here's 180. The first angle that our calculator turned out was minus 15.07. That's over here by 15 and a bit degrees. Where else do we get height that is, it's not a very straight line. We get height here and we get one here. Well, this is 180 plus that little section. So we're going to get another value at 180 plus 15.07. What does that give us? And we've got one here on this section. This is 15.07 back from 360. So we want to work out those two values. Doing that on your calculator should give you 195.07 degrees and 344.93 degrees. You could have got there via cast. Here's our cast diagram. We've got sine being negative in our original equation, so that is there and there. If that is 180, this section down here is 180 plus our relative acute angle, which is 15.07. Well, that looks familiar. That's that. This bit over here is 360. Take away our relative acute angle. And so that is that angle there. So same thing from cast or the graph. That's our middle part of our process. Now we move on to the new part of our process. Now the new part here is these two values are not the only ones up to 720. They are the only ones up to 360, but then our curve starts to repeat again along here. Or on our cast diagram, we could do another full revolution. So let's record that little fact. So sine repeats every 360 degrees. So what do we have? Well, we can have that plus 360, or we can have that with another 360, and that will give us two more values along here. So we have 195.07 plus 360, and that will give us a value. We have 344.93 plus 360, and again, that will give us a value. This one here, when you check it out, gives you 555.07 degrees. This one here gives you 704.93 degrees. Now, having worked through all of that, it's nice at the end of a question that's as long as this to summarize our answers. So I always do this. In these long trig questions, I always make it really easy for someone marking my test to find the answers that I've got. This doesn't count because it's not in the range between 0 and 720. This doesn't count because it's a relative acute angle. So never give your relative acute angle. If you've dropped the sign in here, then that's not going to give you a solution to the original equation. Technically, this is, with the negative sign in there, technically is, but it's not in the range that we're interested in. So our four answers are just these four here. So we've got 195.07 degrees, 344.93 degrees, 555.07 degrees, and finally 704.93 degrees. You might be wondering, okay, you can just add another 360. You can check that if you add 360 to this, and there would be no harm in doing this. You could have done it. It'd be okay. But you would get a number bigger than 720. So that would not count. So there is an example question. Here is one for you to try. So pause the video, have a good go at this, and then I will run through the solution in just a minute. But have a go first to get your head into what is going on. Okay, good. Hopefully you've had a shot at that. So in this one, try not to move it off the screen. In this one here, we have x equals cos to the -1 of 0.43. That should have given you 64.53 degrees. That is also your relative acute angle in this case, because we're working with a positive. So this is going to be one of our solutions at the end, because we started with a positive value. And it's within our range between 0 and 720. So where does that lie? Well, 0.43 about there. So we've got one value here and one value here. That's coming along by 64.53 degrees. So that's going to be the same as coming back from 360. So we could do 360, take away 64.53. If we do that, we're going to get 295.47 degrees. Cast gives us the same answer. Where is cos positive? Well, it's positive here and here. This is 360. This one's a relative acute angle. Down here we have 360 minus our relative acute angle. So that gives us our other one exactly the same as this. Now cos also repeats every 360 degrees. And given that cos repeats every 360 degrees, we do exactly the same as we did last time. We take our angles, so 64.53, but we add on another 360 degrees to get another answer. Same thing with that one, 295.47. And we add on another 360 degrees. So this one here is going to give us 424.53 degrees, and this one here is going to give us 655.47 degrees. List our answers just to keep everything clear and neat. So our answers here were 64.53. And next answer was 295.47. Then we had 424.53. And finally we had 655.47. So that gives us our answers. Hopefully that makes reasonable sense. It's a little bit of an extension to what we were doing last time, but that idea of adding 360 on to get other possible angles is our key idea. I'm going to do two slightly harder examples in the next video. One of them, just so you've seen one involving radians, and the other one which has a slightly more bizarre range to work in than 0 to 720. You might want to have a go at some straightforward questions with these ones. Get your head around this before watching the next video, and then come back, watch the next one once you've had a bit of practice. That might be a good idea in this case.